Hello, students. A very warm welcome again for the part three of real number. I hope you have gone through the first two parts and you have done your work so far. Now, today we are coming into the third part to discuss the third lesson of real number from your book. Okay, before that, some important points are to be discussed. Some important recaps. Actually, I told recaps because these things you got in class 7 and 8, irrational numbers, right? Any number which cannot be expressed in the form of p by q, where q is not equal to 0 and p and q are integers. If you are unable to express them as a fraction with integral numerator and denominator, then that is not a that is not a rational number, rather it is irrational number, right? And then next is rational number, just the reverse of this. If you can express them as p by q form, then uh, q is not equal to 0, p and q are integers, then they are said to be what type of number it is? A rational number, right? So this you have to understand. This you have to understand before really we start with the next important point. Now let us talk about another important point of decimal expression of rational number. We get these things in detail in the next video, but just to start with here, also I give you a glimpse of these particular results, which already actually you know. So I would like to give you this, even if these are not the requirement of this particular exercise. Decimal expression of rational number. Every rational number is expressible as in the decimal form. Every rational number, right? Be very alert about that. There are two forms. Terminating decimal expression. Terminating means decimal expression will be ending, finished. That means if you go on dividing, even if decimal comes, your division will be finished. For example, if I ask you to divide this by 4, right, 10 by 4, your division will be finished like this, 2.5, right? But other one, you see, non-terminating, it should be by, but, sorry for this mistake, it is but, non-terminating but repeating decimal. If instead of 4 I ask you to divide 10 by 3, what exactly you are supposed to get? It is 3.33. Like this it will go, or repeating, it will never be ending. So this is the another category of rational number, which is this one, and this where the division will be finished, this is the first category. So these two are the two types of rational number which you have to take. Okay, uh, you are having now a very important question. Directly I'm coming to that, but before that, definitely I would like to tell you that there is a very important theorem which I did not give the space, so I'll write the theorem here first and then I'll go for a proof of it, or just wait, let me do one thing. Create a space for you. Sorry for this disturbance. I'll write the theorem here in the last slide, and then okay. So now the theorem. Okay, so what theorem it is? Very important. Okay, so you will get the theorem in the book only. If any prime p is such that such that P divides a square, P divides a square. In symbol I have written, then P divides A, right? These things I can write in sentence. P divides A square, then P divides A. Very important result, right? Now, what we understand from here, let us try to discuss that first. Okay? What we'll understand from this, I will just explain you. You see, in the last slide, we have got the fundamental theorem of arithmetic, which tells that every integer can be expressed uniquely as the product of its prime factors. So, this a is any integer. So, this a can be also expressed as product of some prime numbers. We do not know exactly how many primes will be there, so we have written like this. Then from here, can you tell me what is a square? A square means every prime factor will have a power 2 like this. Am I clear to you? Very fine. Now start with this. P divides a square, right? P divides a square means P is a factor of a square. But remember, we told P is a prime. So it is a prime factor of a square. Now just you see from here, a square is a number. This is the prime factorization, and fundamental theorem of arithmetic guarantees us that whatever prime factors are coming here, they are only the prime factors for this. No other prime factors are possible when you break a square in any manner. So, if P is a prime factor of a square, then very definitely this P must be one of them. So, I must write P must be one of P1, P2 or Pn, right? P must be one of them. Okay. Is that clear to you? Is that clear to you? Yes. So if P is one of them, then will P be a factor of this number? Obviously, because that P will be somewhere here and then that P will be able to divide this. So I can write P is a factor of A. I have given you a quick proof without writing much more sentences. Right, so you observe the statements and then try to rewrite the complete theorem yourself, but that is a very important theorem. Again, I would like to tell you that the result may not be true if that is not a prime. I'll come back to that slide again and I'll talk about that, but presently now let us do this. Prove that the following are irrational. I started with root 3. I could have started with root 2 also, that is there in the example only of the book. So once you go through, then okay, fine. If you get any problem, I'll do that. Now let us concentrate on this particular question. They are asking you to prove that root 3 is irrational. Okay. It is not very comfortable for us to prove it directly. So we'll go for a process called contradiction. Contradiction means we'll consider the result to be the negative of what they have stated. मतलब उल्टा लेना है. जैसे they are asking you to prove that this is irrational, so we'll start considering this as rational. So we'll write, if possible, if possible, let root 3 be rational. Root 3 be rational. Okay. If this is root 3, which is rational, I considered, rational can have what kind of expressions? Can you remember? It is of the form p by q. So I can write, therefore, there must exist two integers pq such that root 3 will be equal to p by q. Obviously, if it is rational, we should be able to write it like this. And these are integers. And यहाँ पे एक बहुत important information, that is q not equal to 0. Now from here, I'm going to take two steps. See, पहले square करेंगे, root हटेगा, फिर cross multiply करेंगे. Okay, I'll show that. Otherwise, you may be getting confusion. So क्रॉस मल्टीप्लाई किया पहले, फिर हमने दोनों साइड को स्क्वायर कर दिया. दिस इज नंबर 1. नाउ फ्रॉम हियर just try to see, p square is equal to 3 into some integer. Can I say that 3 is a factor of p square? Yes. From here it is very clear that 3 is a factor of p square. If 3 is a factor of p square, it means 3 divides p square. And now try to remember, what about this 3? Is 3 a prime? Yes. So I can apply that theorem. That theorem means what I explained you now. So that tells you that this divides p. But do not forget to write here in this place the theorem statement. So here what I obtained, 3 divides p. So can you verify the steps? Root 3 I considered as this. Then we did a multiplication, cross multiplication. So it will be p equal to root 3q. Squaring it, p square equal to 3q square. 3 is a factor of p square. That means 3 divides p square. And that will imply 3 divides p by the theorem. Okay, if 3 is dividing p, I can write p equal to sometimes of 3. M is an integer. Can you understand? If 3 is a factor of p, definitely p can be written as 3 times some integer. I have written this. Now this value you put in equation 1, right? Therefore 1 implies, if I put here, it will be 3m square. That will be equal to 3k square, 3m whole square, right? This will be 9m square equal to 3q square. Which value I can cut? 3 I can cancel. So I'll be getting 3m square equal to q square equal to 3m square. Now just you see, this is the second equation. Can you compare both the equations 1 and 3? 2 are almost of the same category, right? So this particular work I'll sort it now. In exam you have to write what. So if I use the first logic what I use here, I can say from here that 3 divides q. I have simply skipped this two steps. 3 divides q. 3 divides q. Now that this one if you want, you can write this as star. this is start as. What will this imply? This implies 3 is a common factor of PQ. Therefore, HCF of PQ is not equal to 1. Okay, here one thing I missed, you must write. There exists two integers P and Q such that this, right? And you must consider that the number is already in the lowest form. That means HCF of numerator and denominator should be 1. This is 1. Please see, this is 1. Means there is no factor common which can be cancelled. But once we proceed like this, we find that there is a factor 3 which is common, right? So if it happens, that means this is a contradiction. So this step you can write. There is no place. Anyway, I'll be writing it here. So please rewrite this definitely in your copy. Okay. So what I'll write, HCF is not equal to 1. Which is, this is the last step, which is a contradiction, right? Which is a contradiction to the fact that HCF of PQ is equal to 1. Therefore, our supposition was wrong. Please write supposition was wrong. If our supposition was wrong, that means what I should consider? Root 3 as rational. This is irrational. So I request all the students to go through this very detail and then do this problem, practice it so that you get a good explanation and good approach in solving this with the clear cut concepts. Okay, this is a very important problem from exam point of view. Let's move on to the next. Okay, you see, prove that the following are irrational. Out of that, this is root 5. So this time I will not write the statement, I will just show you the mathematical part. Actually, it is just the ditto copy of the previous problem. प्रीवियस प्रॉब्लम में जहाँ 3 था, अब उसको 5 बना लो. You make 3 5, then you will get the answer of this. So anyway, I'll just show you the mathematical part. Statement already you understood. So my first consideration will be what? This is rational. So this I can write as P by Q, which will imply in turn directly I'll write P square equal to, I did the square also, right? Multiplying the square. So this will imply that 5 divides P square. If 5 divides P square, theorem says 5 divides P, so P will be equal to 5m. Now this 5m will be kept put here. So what will I get? Sorry, this I have to remove. Where I have to keep P square के जगह में मुझे क्या लिखना है? 5m square. Then this is 5q square. Like the last problem, you can easily observe and compare. Last time it was 3. So this will definitely again say that q is equal to 3 times something, or rather you can say 3 divides, sorry, I'm in the mind of it. 5 divides q. So this is 5 divides p, this is 5 divides q. That means 5 is a common factor of PQ. Therefore, HCF of PQ cannot be equal to 1. Right? Here when you make a supposition, be very alert. You should consider very definitely that they are relatively prime. So this is a contradiction. and this contradiction will definitely lead you. You write the statement, please. Huh? Is irrational. Actually, whenever you get any prime number on the root like this, always they will be irrational, and the proofs are always same. So I'll skip the proof of this. See, ये सब proof मैं छोड़ दूंगा because this time you replace previous 5 by 7. Then next you come 17. Okay, number is bigger. अच्छा, there should be root like this. The number is bigger, but your regions are very same. And if the number is bigger also, calculation will not be bigger one. You don't worry about that. Next is root 41. Here also it is here. Root 41. I think I should not do it. Right? I should not do it. What is the next? Okay. Before that, see, in a general note, we can ask you to prove root over p as irrational, where p is a prime. Let me go for the proof of this. Okay. क्योंकि ये छूट गया था मेरा, we have left it, so we'll be doing now. P is a prime, so statement this time also I'll not write. On the contrary, I consider that this is rational, so its form will be like this. Remember, a b its f is 1, b is not equal to 0. So now if you cross multiply and square, you will be arrive at this. This tells you that p divides a square will imply p divides a. Okay, p divides a implies means a equal to p times some value. Fine. Now a is equal to pm, you put where in this equation. So if I put here in this equation a square means it's p square m square is equal to p square b square. So from here you can see that there will be p cut, it is m square and b square. Now b square will be equal to, sorry, this is not square, right? This is not square, this should not be there, pm square. Now from here it is comparable, right, like this. So I can use the same logic and say that p divides b. Now you see this and this, p divides a as well as p divides b, right? So this will imply what? This will imply that p is a common factor of ab, but HCF of AB equal to what? 1 by supposition. That means this is a contradiction. So as we have concluded, this contradiction will lead you to conclude what? Just think. It will simply lead you to conclude that your supposition was wrong. That means root P must be irrational. Okay. So once you go through, and then if you find any problem, please do let me know. Now come to the second category of problem, which are easier. Prove that the following are irrational. Actually, in the exam, they might mention or they may not mention that these quantities under the root will be considered as irrational. Right? That means in these particular questions, you need not prove root to be irrational, but on the other hand, you will consider them as irrational as a given number, right? Irrational. You need not prove them to be irrational. Am I confused? What I mean to say is that when it is a stage coming, root 2 I can consider directly as irrational instead of giving this bigger one. And this facility is available when your numbers are like this. But if your numbers were like the previous question number 1, then you have to give the complete proof. Am I clear to you? Okay, now let us start with the number 1. Space is less, so I might delete some of them. Starting point remains the same. we'll consider on the contrary statement. You can follow please, and you note down, then you rewrite it. I'll not write here as since space is less. Let this be rational. If this is rational, this can be always expressible in this form, where a and b are integers with q not equal to 0, HCF is 1. Fine. Now in these kind of problems, the facility is what? You already knew that these root over quantities are irrational. So just separate them. Okay, separate them. Root over 2 you bring to the right side, this at the same time to the left side. Now from here very clearly you see 3 is a rational number. You consider this as rational. What will be the difference as of two rational numbers? Result will be a rational number, right? And what about the root 2? Because you can consider this as a standard irrational number. Irrational. Now can a rational number be equal to irrational? No, because on the first slide we came to know that there is no common number in rational and irrational number systems. So this is a contradiction. Which is a contradiction? And why this contradiction arises? Because you forcibly considered that this is rational. So this contradiction will definitely force you again to rewrite your supposition, right? Your supposition should now be what? Or your confirmation should be now what? That this is irrational. Okay. So now it is worthless to discuss this. We'll come to this. Number 3. 1 by root 2. Okay. 1 by root 2 I'll consider on the contrary like this. So root 2 will be this. Now it is very clearly irrational and this is rational. So can a rational be equal to irrational? Again same concept. So it is a contradiction and therefore it cannot be true that it is rational. So it is irrational. Coming on to 4. 4 is an important question. You will consider, you see there are two roots involving. Had it been one root, you proceed like this. Now if there are two roots, you consider like this. One of the root you transfer to the other side and then do square. ये हो जाएगा 2. Left part will be what? A minus B. Say I'll be squaring a 2, and then it will be what? A square by B square minus twice A by B root over 5 and then plus 5. पूरे एक्सप्रेशंस को देखो एक बार. रेशनल कितना है, इरेशनल कितना है. This is the only part which is irrational, the rest are rational. So everything which is rational you please shift to the left side and simplify. तो 2 minus 5, या फिर एक काम करो, ये माइनस है तो इसको ही लेफ्ट साइड में ले ले. That will be a better option for us. 5 यहाँ से 2 आ जाएगा, 3 हो गया, and then this is a square by b square. I need this root over 5 common because I have a concrete information about root over 5 that it is irrational. तो बाकी सबको इधर लेके आने से this can be simplified, right? And then this b will go up and then 2a will come down. Overall impression is what about this? It is rational because p by q form में है. ये irrational. Contradiction आया ना? So contradiction आने का क्या मतलब हुआ? Contradiction आने का मतलब है ये जो हमारा supposition था कि this root 2 plus root 5 is rational is wrong. Okay. Now okay, I leave this for you as a homework, but remember there is a googly, right? There is a point. turning point. Because of that only I am leaving it to you. Just try, because this number is not prime, this 6 is not prime, it is a composite number. So will it be irrational? Yeah, you all know that this is irrational, but please go for the proof, right? See you again tomorrow, right? Bye. Thank you so much. Okay, bye bye.